um, you build these patches, and they're basically um, they're documents that live on your computer and your computer only, and
Right.
trading them around the internet is actually kind of a little bit of a task, right? Because
Yeah.
they have unknown dependencies. They have
Well,
um,
you're basically you've got the same issues that npm and all package managers have. You just
yeah,
made a package manager problem.
yeah.
Um,
But like, what if you didn't have that, right? Like,
yeah.
what if when I made my object, it was like already linked in? Basically, what if the canvas was infinite and
Yeah.
everybody was on the same canvas?
And what's the difference between a synth versus a song?
Right. Exactly. It's like you have synths are basically ways of turning MIDI into sound.
Yeah. So
Um,
synths would be like your package dependencies,
mhm.
and your little code module would be the actual song.
Yeah, and then it's like a whole flow-based programming model. Basically, you'd have to build on top of it. But like the underlying stuff, like the other thing that's kind of cool is that the browser has really good sound primitives in it.
It has outstanding, like the web API for sound just blew my mind. I was like, I don't even think Windows has anything
Yeah,
close to that.
yeah. It's such a missed opportunity that nobody's ever tried to build anything on the web environment
Right.
in
Okay.
JAWS
So
or
is the demo project or the architectural test then making an environment where it's content addressable sound components that carry attribution with them?
That's yeah. I mean, that's more or
Yeah.
less what I wanted. Is like you build
Okay.
the synths, but there's multiple levels to it. That's interesting, right?
Yeah.
It's
Yeah.
like you can not only build the actual processor, but you can then build the program that you're putting into the processor and
Yeah.
attribute that as well, right?
Yeah. So you'd end up with something like npm, which had all these different modules that do different things. You'd have some of those modules would actually be a front end implementation of like something that looks like Ableton Live or a Loop Machine or any kind of interface you like. You'd have adapters and interfaces to different pieces of hardware, and
Mhm.
then you'd also have this store that looks like Spotify, so that people could like purchase songs, but also say how they want them to be different, and request and fund songs that haven't been made yet. And you start spreading the payments out to all the dependency trees.
Yeah,
Every time it gets played, and you get the royalties by leveraging the copyright laws that allow you to charge for songs.
100%. I think like music is going to work better than almost any other type of media in this environment because everybody knows you're being referential when you do music anyway, right? Like it's
It's hard not
like
to.
yeah, people are just kind of a little cheeky about it now, right? Like they slip in references and try to make them far enough away. But like, what if the royalty like calculation was a lot more linear?
And what if it didn't matter? Like you could completely copy someone, and then that means it's like 99% royalty, or you could alter it slightly. Like there shouldn't be a boundary. It's just an alteration of the royalty calculation.
That's right.
That's all
Yeah,
that changes. And if
yeah,
you're far enough away to be completely unique, then you get it all. But maybe no one will listen to you because it sounds like just someone screaming in the toilet. I don't know.
yeah. So
Okay. Well, that sounds fun.
there's a couple questions in there that I think are really interesting. What degree do we rely on the browser APIs?
I think absolutely. Because why not? Like it's all of those elements require a common operating system to target, and targeting the browser as that interface is.
It seems to be the way things are going anyway with Deno, right?
Yeah. And I mean, like, if you're gonna to be able to say, hey, what are you guys doing? And you like go to this web link, and then this entire like synth studio turns up, plus like a bunch of, you can watch people actually using it live in front of you as they try and figure out how to use it. Like that sort of, it's like so little effort from their part, so much reward.
Yeah, yeah. I think of it as basically view source for music.
Yeah. Well, it's more like you had to start even earlier than that, because you had to make markup language for music.
Right.
Right. And then
So
your own W3C standards authority, and on and on and on it goes. But yeah.
So in the code
why haven't you started on this?
Because I wanted a database that worked for it, right? Like, I literally think that this system is the database that works for this application.
Is there any other database that works?
I mean, and I can't imagine how. I've run into so many problems trying to play around with these tools already, and only in like academic context. I don't really right? But like, there's all these sites on the internet for sharing patches with each other, and like, it's always a pain in the ass to pull it in and figure out exactly how to link it up properly.
Yeah, it's painful. There's no clean interface.
Yeah. So what I've sent through in the code topics is basically the PD homepage.
Okay.
And I, PD runs as a C program on top of Csound, I think. So it'd be hard to make this target the browser. It kind of targets
right. But I don't know, is there that much IP bundled up in this library that you have to use it because it's too much work to just build little bits as you go?
No, but I think as an inspiration, it's kind of got all the stuff that you're going to need to think about, basically. Right.
Okay, so it's the architecture and the thinking that you want to extract out more than the actual code itself, right?
Right. I would suggest that like a nice little experiment would be, can we just save a WAV file on the system and then use the WAV file as a sample? Use the WAV file as a sample in something else.
Right. So can I get a doc going so that we can actually start to write up a spec here?
Mm-hmm.
Let me just find where that would go. Make a new document. Please name your project. What is the name of this thing?
I don't know. I hate names.
Everyone does. Okay, well, for now it's called Meow. And,
okay.
Link in the chat.
Let me open that in. It's frustrating that I have so many
identities
in my Chrome. Yeah.
But you switch to a different user when you switch who you are? Try and run them all out of one Chrome identity.
No, I have multiple Chrome identities now.
Oh, right. Okay. That made my life so much better.
Yeah, but now it always opens the wrong one.
So the test is to save a WAV file on the platform and do what with it? Have a link to source?
If I could take a WAV file, so there's kind of two, I think, key like ground level components for the application. I guess let's forget about all the rates and stuff like that, right? So there's basically two pieces to an audio application. There's the actual 44 kilohertz layer, which is where the audio samples go into, and it runs really fast, and the file sizes get relatively big, and you can't really emit signals that fast. You can only really emit audio that fast. And then there's the signal layer, which is running at about 100 times slower, maybe 1,000 times slower. And the signal layer is allowed to change things inside of synths that are usually reading to and writing from wave buffers.
Okay, so there's two layers to an audio program.
They call it audio rate and signal rate, AR and KR. I don't know why K. Control rate, I guess.
And signal rate. AR. Where the audio rate is too fast.
Buffer, like you have a buffer that you're writing sound samples into or reading sound samples from.
It's too fast. It's too fast for a computer to process. Too fast. It has to be processed in hardware, and your computer interacts with that hardware with the signal layer. Is that right?
That's right. That's right. Yeah. And that's actually the way the web API works, right? It's the nodes, the sound nodes have buffers inside of them. They speak directly to your speaker. You speak to them through some kind of control layer.
Users.
Hey, do you remember who you added this file to?
It should be everyone who's got access to Dreamcatcher docs. I'll just send you the full link. You should be able to go in it now. Anyone with the link, you go. You go. Please.
No. Oh my god.
Everyone's allowed. There's no more permissions. Share it with the entire internet. How can you be excluded from that group?
Well, it looks like I'm in. Okay.
Okay.
Editors meaning people you model. Oh, I see. I don't know if it's worth like putting inspirations in, like PD, like Linux, or do you think that it makes sense to try and work from a fairly low level?
I was trying to bend it to use the Dreamcatcher components, but slightly more focused. I think what you're talking about is what to insert in from the audio side to meet that, so
Right.
we can put those in.
Well, I mean it more from like a UX perspective, I guess. Like, and it doesn't really matter what the UX is, I guess. But
So editors, I would say like PD.
yeah,
But we'll call that distributed.
and What do you mean by link to source here? It's just like with authorship information, or
What?
you say?
With a link to the source program.
Oh, okay, right.
Because if I give you a wave, you will struggle to reverse engineer it. It's like sharing binaries versus sharing source.
Right.
For some reason, the music world hasn't terribly gotten into the whole sharing the source thing. Everyone just consumes the binary.
Right. Which is like destroying the industry, basically, right?
You could say that about software, but both paradigms have survived somewhat.
Later tests are going to be things like load audio buffers into packages to process the sound, feed signals. To store signals on the platform. Great, I think that's like I could see there's a really, really interesting interaction here where like I'm tweaking the knobs, right? And I'm mutating the sound, and it's kind of recording into a sequence of pulses. And then at some point I want to pick up all those pulses and just say, like, that's the definitive recording, right? Like that's the definitive like knob tweaking for this song, right?
Yeah, so that's version 0.01.
Right.
And you can just simper it up.
Right. Exactly. And like when you like load your song from the Spotify store, like all it really is just a bunch of like
it's latest
with knobs tweaking on it, right? Like
yeah, the store is latest, but you can roll back to previous versions and you can see what it used to be like.
Right. Ooh, fancy. Is that like what's it called? The how come I can't remember the name of that app anymore? The one that you let it listen to the music around you and it tells you what song it is?
Shazam. No, that's not that.
No.
So each time someone listens to it, it gets a new fingerprint added, so that when they
Right.
share it, you can trace how the virality of the piece
Right.
occurred, and you can pay out to that. So if you're like the first one, and then you introduce everyone else to it, if it goes to like 20 million views, you'll be getting a tiny slice of that every time.
Oh, interesting. Sharing as like
sharing as an activity rather than
Yeah.
something that you sort of, like how do you get paid for it right now, right?
Right.
You don't.
So instead of the gift that you give to Zuckerberg, right?
Right. Right.
I never thought of that. That's a really
If you can focus on money into the system, then if you disperse it out fairly, the idea is that surely it will grow. Okay, so what did you get into?
I don't know. I just tried to write down what I thought was like least to most complicated. So like basically a primitive for audio buffers, playing back that primitive, like playing it back inside of like another package where you can mutate the sound.
What is the relationship between the processor and the original content?
So there's this idea of freezing in audio, right? Where you're going to take some input of like sound that's either a sample or an empty buffer that you're feeding with a synth, and
Right.
then like you're going to feed the control information into it, and you're going to generate some kind of actual like flattened version of the sound, right? It's like flattening a Photoshop document, basically.
Yep.
And
You took out all the layers.
Yeah, and that's the thing that usually gets distributed around to music platforms now.
Mm.
So I think you're not going to get away from the need for some kind of a performance, I guess is what you would call it, right?
Yep, a specific performance.
Yeah, people aren't going to want to regenerate the entire performance from scratch.
It'd be like compiling your web page from source each time you go to it. You sort of don't want to do that.
Mm-hmm. Exactly, right? So, some of the artifacts on the system are going to be like performed playbacks of things. Some of them are going to just be like waiting, just buffers that are just waiting there to play back as you hit the metronome on and you start tweaking with the knobs, basically,
Right. Okay. Okay.
Now, I think probably the most interesting artifact in the entire system is probably the performance audio file that's still linked back to all of the actual information about how it was made.
Right, because that's what you're interested in if you actually want to compose.
Exactly.
Yeah.
It's like a thread break almost, right? From the creative process to the consumption process. But like that's where all the information is currently lost in all the like music applications, right? You don't ship your DAW files when you ship your audio to Spotify or whatever, right? I don't know what's the best way to like think of it and build it in terms of what you've already built here, right?
Definitely the content is storing binaries is easy. It's like it was actually harder to store JSON than it was to store binary. I found the prefers binary. And then there must be standard formats for project files, right? Like Ableton Live project files versus like you kind of want to be compatible with tools that people already know.
Right. So some of the components here, please feel free to like move and change any of this as I'm writing it, because there needs to be some kind of object that's like a wave file. That's actually literally what the current programs use is wave files, because these are basically just uncompressed samples of sound from sound input.
Yeah.
There is MIDI files,
And that's more like the signal
Yeah.
end, right?
Yeah. So this is a like signal file, and then there's a newer standard. This is an old standard that I think is the most widely supported, and the reason you'd want to make sure MIDI is baked in is because you want to be able to plug your keyboards and stuff into the computer and use whatever interface you want, right?
Yeah.
And then there's a newer format that's like a replacement for MIDI called OSC. MIDI is a horrifically bad language. MIDI, it might as well be like go-tos, where OSC is like functions basically for control rates.
Yeah.
And, like, what does a song look like in view source mode? It's going to be, a collection of audio buffers, probably empty, with sound generation devices outputting to them. A feed of control information into sound generators, and then a layer that muxes all the audio buffers and normalizes it for output, so you don't destroy your ears. It's like a very, very, very big task to get all these things in there, but I think that the main primitive is basically just like in terms of computation, the main primitive is these packages, right? They take control rate information and then they feed audio rate information into the buffer.
Right. So you want the packages need to. Sorry, I'm a bit slow to type. Packages. So you want to make distinction between sound processing and sound content.
That's right.
Interfaces. Components are visually wireable together. Okay, I'm just going to read what you were writing.
Uh,
Would we have lost something if we're just, say, supporting Ableton Live, making like GitHub native Ableton Live project so it can detect that, hey, this is an Ableton Live?
like you're saying you want to program to live instead of programming to like a low level interface for sound.
No, I'm saying that I want the low, but these other aspects around it, like the store, the project management, these aren't required to generate a revenue stream.
Mhm.
They're not required. You could just do it yourself, the low level thing off your own back type of thing. But if you had the store, it becomes easier to see why it's useful and to generate more interest in it. And
Right.
I don't see why you couldn't support other editors, just like
Sure.
you have like a JetBrains IDE and VS Code and Visual Studio and all these other things, and they all put their own little files into a project and all that. It's like
Right.
how
So it's
they
working
all,
the outside in.
they all have a notion of a store,
Mhm.
right? Whether you buy plugins and packages, we should be able to make one second.
Mhm.
Terrorist got lost. Can you go from Ableton Live and click publish to Spotify? No, right?
No, definitely not. No.
What about SoundCloud? There are some that are getting close to that sort of function, right? Like you make
Yeah,
music.
there's
Okay. Can you from Ableton Live go publish to Fruity Loops store? Like what I'm trying to get at is that if you want to publish to each of these software components have tried to make their own store.
Mhm.
Interaction between them is difficult. That's the same n²/2 problem that we see time and time again with connecting enterprise services together. If you all connect to one, it's way less work.
Right.
And if that one is sort of like the system bus between them all, like I know it's foggy what I'm saying, but
No, it makes sense. Like just to start with, the pairing between the end result of like what you've made and the setup you've used to make it is
right.
like useful enough by itself.
Exactly, because you don't want to be like sharing your Ableton Live project just to get like your grandma to listen to what you've been working on for the last few months.
Right.
You want to just like send them a single link and they go, oh yeah, cool.
Yeah. So I mean, as long as there's a way to kind of like work backwards from there, and I think there is, to like, I think the more fine-grained you can get with being able to use chunks of projects instead of like whole entire files, basically, the more useful the application would be, right?
Right. So it's like you're allowing music's supply chain provenance to go with your song.
Right. And encouraging people to basically take your thing and modify it, right?
Yeah, or if they like it, to promote it, because there's an economic incentive in sharing it.
Mm-hmm. Okay. Yeah, I mean, I think that's already probably a lot. Yeah, I mean, I was always jumping to the kind of like crazier version of it where you've built the entire DAW on a browser, and like
The entire what? Sorry.
The entire digital audio workstation on the browser. Like you
Yeah.
build
Or
Ableton Live inside the browser, basically.
tell me what the benefits of having it there would be.
Yeah, I mean, so the easiest answer to that is to, like, if you've ever played around inside of Max, one of the design advantages of it is um, I can take like a very tiny fragment of my of somebody else's project and just like put it on my patch and then connect it in whatever way I want it to be connected in. And it's not even the same thing as just taking a sample from somebody else's song. It's literally taking part of the logical guts of their music
Yep.
and then using it, right? So like
Right.
the more we can capture those like details, I guess, inside of a system like this, the higher the degree of referentiality becomes.
The unrecoverable details of the process that made the thing. If you can capture the process that made the thing and make that shareable and accessible, surely that's better, is what you're getting at, right?
Yeah, I think it's hard to explain without actually firing up Max MSP and starting to build some stuff in it. But like the normal workflow there is basically you open the help menu, and the help menu is just a bunch of actual living documents that have like the programs built in them, and you just copy chunks of the programs with whatever kind of like you leave dangling wires, right? And then you attach the wires into the rest of the things that you're building. Right. And then you hit the play button on the new thing that you're building out of pieces, right? So it kind of allows you to like just like take any level of complexity. You could take an entire synth from somebody, or you could just take like their particular way of generating MIDI sequences or whatever, right? And like you could just drop it right in the middle of yours. And what's missing from all of this is basically like if I want to do that online right now, I need to go over to maxobjects.com and like surf through all these broken things that like complain about bad Python environments or like missing other patches that this patch uses, right? But the idea is that audio and control flow around a bunch of different wires in this thing. And like anything can kind of be attached to anything else, basically, right? It's like a really, really, really profoundly easy to use programming model for music. I don't know that I'm explaining it very well. It's like
keep going.
Yeah, if I
well, maybe while you're thinking, I can explain some of the benefits that I would see in.
Yeah.
So I am starting to form this notion that we can build an application that is a bundle of isolated components. So, for example, when you're building a piece of CAD software, the ones I've programmed for, you can sort of write your own component that has access to the world view, the 3D model. It has access to this API inside of it. You can change the view, add pieces in, and you can wrap that all in a series of buttons that you control in this panel that you supplied. Breaking that down further, I don't see why you can't actually assemble the entire package of a thing in that way, so that there's no really referential version of the software. It's like this package of these tools arranged in this way. And so you can, if you split the revenue stream between the panels based on who actually clicked on what and what tools the person was using, then you can incent the construction of the software without having to like do this big upfront investment, build this large thing, get your users in there and get them trapped on it, and then start selling off a marketplace for little modules and plugins over time, right? You start with the module plugin market first and go from there, tuning as you go to fit the needs of the people, as opposed to trying to sort of reverse that back in afterwards.
Right. I mean, if you start with the like monolithic software thing, and then you say this is what it means to implement a plugin, right? I've left these wires exposed, right?
Yeah.
And you can attach to those wires however you want.
Right.
But instead, you're just saying there's nothing but wires, right?
There's
like
nothing
all
but
the
wires. Yeah,
are exposed.
all the wires are exposed, and here's a referential design from us.
Right.
Doesn't have to be that way. Tell us what's wrong with it, improve it, get paid. We can stump up some initial funding for some of that work to get off the ground, and we can go around and solicit further funding to do things that we're getting good signal from the market. Like we're like, well, we made these changes, and these modules are quite popular. Part of the usage analytics now becomes like, instead of telemetry being something hostile to the users, it's something they want because they're going to get paid. They only get charged for what they used based on telemetry, and they get rewarded for using, trying, and feeding back on features that they used first or that they asked for. So it makes them more engaged with the software package because it can adapt better if they pitch it as more.
Right. Yeah, I mean, it's going to just work this way automatically with music because it's already the way people are doing things, right?
Right.
The problem is the software gets in the way of being a good musician right now. Like, you have to worry about all these compatibility shims and like bridges and stuff like that, right?
Yeah, and everyone's trying to build their own little empire, right? But the musicians don't care about that.
Right. Like imagine you play like a really, really good drum sequence on your electronic drum kit, and I love it, but I just hate the drum sound that you picked. So I'm just going to take your playback. Yeah, exactly. I'm just going to take your playback and I'm going to like put whatever samples I want underneath of it that came from that other guy, and like you get paid, they get paid, I get paid, and like that's what musicians want, right?
And you don't have to think about it.
Right. I want to
So we're moving from download this song to upload this song.
Basically, I think there's a call for a store that has like the mixed down kind of more concrete versions of everything, because that's still how consumers listen.
That's what I want.
Yeah, but like for sure, what I want is like if you download it, you get everything about its provenance, right? Like you get everything about how it was put together, all the way back to the first person who used the platform, basically.
Yes.
And like the reason why audiophiles will like that is because right now there's some like magic stuff going on in Spotify that's like you listen to this, other people that listen to this also listen to this, and all this weird calculation, right? But all the music nerds I know, like what they want is like, I listened to this, I liked it, I looked at how it was built, I saw all the other influences that influenced it, and like I listened to the things that they made, right?
Right.
So
Okay,
like
so
even for the consumer, there's a benefit here, right? Because like, I don't have to do this like sounds like thing.
Yeah, you can do source analysis as part of the discovery algorithm.
Right. But unfortunately, there's a lot of primitives that need to be built for that kind of system, right? So like figuring out what the tip of the spear is name them. So I mean, I think you need like basically like a recording buffer to take audio in from the outside world. You need a signal rate buffer to take in playback information from the outside world. You need some kind of like generic idea of what a synth is, right? So it's basically something that converts playback information into sounds. But if you think about it from the perspective of just the wires, right? It's always like this thing maps a control signal into an audio signal. This thing maps an audio signal into an audio signal. This thing maps input into audio. This thing maps input into control. This thing maps control into output. This thing maps audio into output, right?
Right. So there must be a programming model for that that's already adopted widely, right? Like the audio guys that made the web API surely must have been targeting something, because I haven't seen a more thorough spec in the web specs than that, right? Like that's an incredibly violently specific spec.
So we have C-Sound, which is the engine that PD programs to. You have PD, obviously, which is like a GUI layer that does start to think a little bit more about the software management aspect of it. I did an entire course on this in university. I just don't remember any of it. This was like something I was really, really passionate about doing until I realized how hard it actually is to work together with people, because the tools all get in your way. I think C-Sound is probably the inspiration for the web audio API. There's this other spec too that like gets used inside of plugins right now. It's called VST.
Oh, yeah, VST plugins, yep.
Which is going to do some kind of like specking of that out. Just realizing I don't have a very concrete idea in my head.
No, it's good though. Like you know, I think we can both see the shimmering sort of mirage off in the distance, and now let's see if it can actually be designed, and let's see if it fits the programming model.
Yeah, I mean, I honestly think that like PD is probably the model to kind of match, basically, right? Because like anyone that's serious about like computer music understands that library. There's it's already built to like run on top of all sorts of like
weird things.
Mm-hmm.
Yeah, okay.
And it kind of like it uses all of the standard interfaces that exist in the field, basically, right?
Right. So that's good, because that's basically our template, and we're just making the web distributed version of that and then bolting on some commercials on top, right?
Yeah. This guy on YouTube, I think, has some of the best like patch building videos. I don't necessarily think we want to sit here watching these, but like if you're curious about the programming style that I'm talking about, I think it's worth finding people who do this live. Like lots of people love to just like mess around with patches and record videos of it and blow your ears up a little bit.
Okay, so how much research have you done to see that it could well be a web API version of a lot of these things already?
Yeah, I did look for a while. Last time I looked, there wasn't a lot of deep stuff that was built on top of the web audio API. There was a lot of still fairly low level stuff. I'll have to look around again to see if that's changed in the last like 5 years.
There's a WASM version of C Sound.
Is there?
Yeah. Tell me, in music production, is there anything that has a large computing requirement?
Yeah, everything to do with audio processing, right? So,
But bigger than a single computer.
no, not so much actually.
So you can really, on a modern computer, you can do all the computation you ever need for a piece of music.
You do run into kind of barriers once in a while, right? So like if you do things like decrease the signal vector size to like 8 bits instead of 64 or 256.
Right, yeah, but that's more like a real-time thing. That's not a distributed computing problem.
Yeah.
Right. Okay. So
Yeah.
what about an issue over something like rendering an ultra-high fidelity version from a huge number of sources?
Right. So the one kind of interesting thing about sound is you just don't need to sample it that like in that much detail, right? I think like 192 kilobits a second is the highest sampling rate you would ever use.
Okay.
Because your ears can't perceive faster than a certain frequency.
Yeah. Okay. All right. So there's really no value in having extra compute power available greater than your workstation that you're currently on.
There's one thing that actually I was playing with when I was doing the class, which is I think like processing lots of inputs and feeding them into the sound can get very expensive. So I was wiring up a Kinect so that when people dance, like you use their motion as input for the music.
Right. Yeah,
I can only handle
a real time. Okay, so there seems to be a natural real time affinity for all the types of computation you would need in this platform. Therefore, a distributed system can't really help you with that because the latency to go off, get your work done, and come back is just kills the point.
I think right. So it's pretty much just the store, like the distribution of the configurations that would be.
There is some other reasons why you might like large distributed computing. If you had in your DAU real-time discovery of similar works, and this can like sort of like Copilot, but for the DAU.
Yeah,
that's a heavy computational load, right?
Yeah, I mean it would be for sure.
Okay. All right. I'm just looking for a couple of jump off points to sell cores. Okay. Well, that's cool.
The thing is, I think distributed, like there's something that's happening inside of blockchain land that's really interesting here, right? Like it kind of naturally muxes signals together, right? So like you can kind of offload some of the work of taking lots of inputs and creating lots of outputs by like feeding them all through common chains.
Oh, like if there was a common synth that everyone used.
Right. Just think if you have like 1,000 people tweaking knobs in a song, like this is something that musicians actually want, is to feed more and more and more input into their like experiments, basically, right?
Okay, so there's a natural limitation on what you can use as a sample in your music that's so far been limited to a single computer. But if you could get distributed sampling, like what is the sound of 1,000 street microphones all around the world, just to pick a stupid example, that's a capability that you couldn't get off a single computer DAU, but you could get a DAU that was distributed that could give you that.
Right. What really starts getting expensive is when you start feeding a lot of audio signals into the same box, right?
I can honestly, I've never dreamed of doing that myself, but I can imagine how the processing load gets up there.
Yeah, I mean, you can really only handle. I've definitely topped out my MacBook Pro, like with just farting around with Macs.
Right.
It's like I don't know. It's like if you ever open Illustrator and put like 500,000 shapes in it, like your computer takes an hour to do anything after that.
I know it never recovers, eh? Even if you reboot it. So, what about if you were, let's say you had a concert, there were 1,000 people with a cell phone, and they were able to feed that cell phone feed back into the DAU, and do something with it.
Right. I mean, that's like a workload that you could probably make something interesting with that can't be done right now.
Yeah,
without
yeah,
distributed computing.
Yes. Okay.
There is this I just found, which is pretty cool.
So I think there's some additional benefits to a web-based DAU, which is that you can introduce it into novel platforms, like in the VR world.
Right.
And, if it comes automatically connected to this wider network of things, you sort of make more money the more people come and use it. The more connection people find, the more chance there is that money will change hands, which is good for us. Okay, feels like we've hit the bottom of what it could do in its fully fledged form.
Yeah, I mean, I just think of it as like you always hit a point when you like draw 20 nodes or 50 nodes or whatever in your patch where like your computer is just starting to struggle basically. And like what if other people's computers were like taking control of like other chunks of the canvas basically?
Okay, so large load of a single computer. Right, so I guess all that matters is that when you hit play, you can have an arbitrarily complex network of wires.
Yeah.
So long as when you hit play, the buffer latency of the audio stream that was going into your ears was greater than the buffer latency between the coordination of the distributed computing nodes.
Yeah, right. You can tolerate a latency of up to like 100 milliseconds before your brain starts to decompose.
Yeah, before you defuse, your brain creates fusion if it's under 100 milliseconds, but the fusion is lost greater than that. But that's a lot of time to play with if you had, particularly if you had local nodes.
Right.
Yeah. Okay. Oh, that's fun. All right. So, what now?
I mean, I want to start building the did you see the last link I sent you here? That's an actual running version of PD in the browser.
PD in the browser. That's neat.
Yeah. So if you turn on the audio output, it's making a ghastly sound. But it appears to be backed by the actual web audio, backend.
Right. So they got a. Wow, that's cool. Hey, that's really cool. This is kind of what about, right?
Yeah. So there's like, it's easier to see once you start playing with it a little bit, right? It's like
so they got a JS version and a WASM version as well. Yeah. So it can run as either JS or WASM.
Like as in web audio or WebAssembly for the audio processing.
Yeah.
Cool. It looks like it's a stale project.
So like, it's a good jump off point to use.
Right.
Right.
And I
'Cause
think you can see it when you start to play with it, right? Like what I think we need to make are the boxes and the wires, right?
that's for the digital. That's for the workstation.
Mhm.
What I'm trying to focus on is the economics behind the assembly of the components so that you can distribute that work out.
Right.
Right? Like you're looking at it like you want this sort of finished thing, and I'm saying if you made it, what does the framework look like? How do we get enough of the framework to convince other people that this is worth putting money into and labor into to just loop a lot?
Right.
This is really close to being useful from the looks of it.
Yeah, there's an open collective post where they're soliciting funding. It is actually not dead. I think the dude is like looking for money to keep going with it.
Yeah, well, we can supply that if you can, because I'll bet he's got no commercial model. Give me money and I'll make this cool thing. Okay. Run your pure data patches on the web, and we are how old? We are a little bit old. We are 6 years old.
Right. So there, in terms of the economics, I think the way that it would work is when you make a patch, like most patches can take inputs and create outputs and be plugged into other people's work, right? So like you can easily make a software storefront with these things. Where like people are trying to sell their work, putting together like units that work coherently together for bigger compositions. And like those things should be forkable very easily, basically, right? Because it's like at the end of the day, this is a JSON file, more or less, until you actually hit the button to start it and start playing music out of it. I don't know if there's a very active community looking into this type of stuff right now. Like you'd probably get more users if you just did a store for Ableton like Live.
Yeah, that's what I was getting at. Like if you start as being compatible with that, then it's sort of like your main goal is to build this DAU that can swallow everything, but you got to stub somewhere,
right?
And you got to get the funding going, right? Like this guy's, I mean, he's just doing it for fun. Like that's not. I mean, Spotify doesn't do it for fun,
right? The only reason I keep bringing it up is just because I want to make sure that no like initial pass removes the ability to hit the end goal, right? Like
I see nothing but strengthening here, right? Yeah. These all look like power-ups, not damage.
Yeah.
Right. Because I mean, we're coming at it with a way to reward open source contributions, and saying that company policy is we pay out to these open source contributions by a formula. So, and here's some initial money to get some things going.
People do pay for devices in Ableton already that are contributing.
I know, right? And they also pay for sound packs and stuff like that, like a lot. And
Mhm.
like, you know, in fact, I think Ableton Live would be the most expensive piece of software I've purchased in the last maybe 10 years.
Yeah.
If I ignore things like autopilot for cars. Yeah. Yep, no, that would definitely, music software is expensive.
Yeah. So do it as a store first, basically, you think? Just like a store for configs for other programs, basically.
I'd say just there's two levels of store. There's the consumer store, and then there's the technical store.
Right. Like the store for the artists and the store for the listeners.
The art store. Yeah, and I think if you just made it with that initial compatibility of using like the Peugeot chain set model,
Mhm.
so that you sort of had this change control built in that was just a lot simpler to use than Git, but still meant that you didn't have to have file storage. Like you could even like do something super lame, like just charge a subscription fee up front, just store your projects here, because it's like a backed up, the safe. There's a plugin for Ableton Live where you can, it's sort of like a OneDrive plugin, but you go there and like all your stuff's there and looked after. You can one-click share with everyone else.
I think they're actually already starting to do that with the like the crate, the sound samples and synths and stuff like that. They're
At when, sorry? Just 1 second. I can't make that. Next time. Okay, so what do we make first? Specs.
yeah. I think that like I think the music storefront is probably the easiest thing to make first, right? The consumer storefront.
Right. I think you need a stub of all of them. Like you need a stub of the project place, which is effectively the artist storefront,
Right.
and then that one-click connection to the consumer storefront, and then a really simple version of the inbuilt DAU. So like I imagine it, you know how GitHub lets you edit files on GitHub?
Right.
That's what the initial DAU would be like, right?
Right. So
Like,
what kind of editing do you think you want to allow? Like,
well, it would have its own custom format,
right.
so it would only be able to edit its own files, but it could reference any content from anywhere on the site. Like, so if you had an Ableton project that had uploaded some samples or had a dist folder where it had built the wave files, you could then consume that in the online DAU's inputs, or
Right.
in another project's inputs as well.
Sorry, I've been wearing these headphones too much. My ear is starting to hurt. Is there a way to do it without building the editor?
Absolutely, but I think the editor is more. The editor has the least friction to get up and running.
Because so there's like a really, really easy way you could approach the editor. You could think of it more like being a direct, like wave editor, right? So like it doesn't have that many functions. There's no like timing and
Right.
input kind of capabilities. It's just like
Right.
it's just functions you can run on waves to turn them into other things, right?
Right. So I think if you
Yeah.
start with that and then build up and make sure that the application is plug-in first,
Mhm.
and then plug-in first can, if it was a covenant first,
Mhm.
then you could sort of run it anywhere.
Right. I think the way you can probably pitch it for the first pass is like a sample store, right? So like you don't even worry about the end users. Just make it like a place where like people get samples. If they change the samples, they can re-upload it. The samples plug into your like sample crate in the music editor, and like they have provenance information. The editor would be really simple then. It would just you could probably even I bet somebody's already built Audacity so it works as a web page. You know what I mean? Like instead of having
It is here. Yeah.
think-
Audacity
think-
Online.
really
Yeah.
think like MS Paint instead of Photoshop.
Yeah. Audacity Audio Editor Online. So that is. Yeah. Looks like it. So that's good. So we can basically put that application in the Dreamcatcher store, and then this sample store is like a separate sort of a thing.
I look
Right.
at it as like the flattest possible version of the thing, right? Where like
Yeah.
you're only ever operating on the audio information itself. You don't have
Right.
to worry about.
So the architecture of a distributed store is such that the samples are flagged as a certain type of thing,
Right.
and then the store, it's the exact same software that powers the Dreamcatcher store, but it's got a different filter. So it's like filter by audio samples, and then that's your sample store.
Yeah.
So it's the software and the back end is all the same. And a lot of you just skin it differently, but it's it's the same thing. And so you can present that same thing within an application to allow you to browse online samples easily as well. And it's all running the same code base, so long as you've got a browser platform as your API target.
Right.
Okay. So where do we
The other thing you could do is you could just say like if I sell songs on the song store, it always has how they pack bonus information into DVDs like
Yeah.
Like making of and stuff like that.
Yeah.
You could pack all of your samples and like Ableton Live files and whatever with that.
Yep.
And then sell that to consumers and artists. And like I think the change detection, like the provenance would be harder to figure out then. Like you'd have to correlate purchases with re-uploads.
Yeah, I think you want to allow it to be full provenance if possible, but you need to be adaptable to severed provenance if people want that.
Right. So downloading and re-uploading is always a way to break the model.
Yeah, absolutely. But that's where things like sound similarity based on what a judge thinks come to pass if things get nasty. But I imagine in a few years there'll be some sort of trained data set that can detect audio similarity between songs in a sort of a semi-standard way. Like,
right.
You kind of want like a copyright bot that like listens to the song and is like, oh, that's 87% different, or but that's really what you want your attribution algorithm to be, because it just listens and then says that's like this, and therefore this is how the royalty stream gets split.
Right.
Okay, so can you at least name it?
Music, Dreamcatcher music.
Look, until you think of something, I'll just go for the.
Yeah,
That's
music,
your name.
right? Right. So there's a lot of fleshing out that needs to go into this, obviously.
Yeah,
right?
but I think those core elements are looking good. Like those are reusable components. You know, like
Right.
the project platform is the same as the Dreamcatcher project platform.
Mhm.
Packages is just like depackage, but just with a different filter on what type of package they are.
Right.
The attribution algorithm is more or less the same. It's just loading the music module.
Right.
And you know, there's money involved here that sort of seems not pie in the sky, right? It's like you're sort of NFTing by default. Everything's an NFT as soon as you made it. You can sell it or not sell it. Recombination of other NFTs.
That's right. Yeah. So like it almost kind of feels like another way of doing merges, forks and merges.
Yeah.
Forks for sure, right?
That's what you want. Yeah, okay. It sounds like you could make the argument that there's money in there somewhere.
Who, like, what's the process for actually going and getting funding? You got to find somebody that's willing to, like, you got to put it together in a way and pitch it and sell it to somebody as like a thing that you want to build with the platform.
Well, yeah, I mean, stub it out, write the packets, specify the packets that need to be done for the first round of it, estimate the cost of that, and then have a guess at what revenue might be. Build the first round, see if we get any takers for revenue, forecast again off that, re-raise.
Right.
Because at the same time, like there's so much overlap with some of the other stuff we've got to do as well, that sort of like the funding can be pulled for like those kinds of elements.
Right. I think stores are going to be a common abstraction to everything, right?
Everything, right? Yeah. And they're really just a search filter as opposed to a thing.
Here's a bit of a philosophical question for you, I think. You know, do you think that like people pay for, like it's kind of been proven right now in current like media and computer landscape that people pay for media files, right?
Right.
Do you think that it's possible to make everything saleable into something like a media file, like an NFT, right? Like, do you think that the model of like buying a good, I guess, works for everything that you can possibly want to do?
Are you saying
Like, I have a feeling that subscription-based software is going to take a bit of a wobbly path in the next few years because there's too many subscriptions already, right?
I think the subscription model's flawed.
Yeah.
I think it was
And-
great at the start, but the subscription model is not good. Paying for the software itself as I used it, great.
Mhm.
You know, like if I stop using it, I shouldn't have to keep paying.
So you view like that's kind of like a microtransaction version of the like subscription model, basically, right? When you do things that are compute expensive, it costs you money. But what I'm wondering is like how important is the idea of thingness basically to people's decision to purchase stuff? Like to me, it seems people like buying things. That's
Right.
why.
I mean, NFTs are a great way to turn a service into a thing.
Mhm.
Um, but I think that there's two psychological forces would influence a decision to purchase in this store. The first one is I want to help the artist, because
Mhm.
that's a thing, because people give that away for free. The second one is if I buy early, I become a funder, and if this goes to mega stardom, I will get royalties for my early purchase.
Mhm.
So there's a FOMO / investment that we'll just have to check we're not falling afoul of securities, but because that sounds a little bit like a security, but basically that's a good reason to buy something. You're like, I'm buying something with the hope of getting money back later.
I love the idea that sharing is like a positive contribution to the system that deserves recognition and payment.
An incentive model, it's the thing that it's the sales commission model. Sharing is sales.
Right.
You are selling the song. Someone else bought it. You deserve a commission. Thingness, I don't know. I don't think that you need to turn things into things artificially just to make a sale on them. I think that selling for the consumption of something is enough. Like I want to play this song once, I'll pay you 2 cents.
Right.
I think that the thingness decision in people's minds really drops off when the amount goes down. Like people stop seeing things as things when they become small. Like people don't
Right.
see grains of sand, they see a beach.
Right. Right. So like you view when you're buying music is always going to be like a service, basically. Like you're paying for a playback, you're paying for somebody to
Yeah,
execute.
I'm paying for an event, not a thing.
Right.
If I want to buy the thing, that's more like an investment. Like I could buy like a $10 share in the song, and then as it becomes more valuable and royalties get paid, I should receive some money to that share that I bought. So you can thingify it in that way.
So the only reason to grant anything thingness is if you want to be able to resell it, basically, or make money off of it through speculation.
If you want to resell it, or if you want to be an attribution target.
Right.
So, for example, a consumer would be purchasing the event of listening to the song, but a funder would be purchasing for a larger amount. They would be paying the supplier or the creator of that song in advance for things that haven't happened yet, events that haven't happened yet, that may never happen. But when they do, there's some formula that we use to split the revenues to the artist and the funders.
Right.
So like a record label will give like an advance to an artist, but they'll collect all the royalties in perpetuity type of thing.
Right.
And so you opening that model up to a smaller market is sort of what I'm getting at with that store.
Mm-hmm.
Because it's no different than funding a software module under our model. You're just like, there's a work of knowledge that doesn't exist yet. Here's a small amount of money to make it happen. But when it does happen, I want to get some of the royalties for having made it happen, because I was part of the team that created it by being a funder.
It's interesting. I mean, I was just reading something the other day that's like the media of the future is going to be directed by the fans, basically.
Yeah.
That's even kind of where you're pointing.
Yes.
I can see that.
100%.
Like one of the things the store should be able to do is if I like something and I want somebody to make something with it, I should be able to buy it even though it doesn't exist yet.
Yeah,
And
buy
then
something that,
somebody will come along and use the thing, like use the patch that I referenced or the like samples that I provided or whatever and make something, right?
Mhm. Yep.
Yeah. I mean, I think that's a really interesting model for any kind of media, actually.
It's any kind of work of knowledge. That's the exact same model that we're trying to use for software. It's just applied to a different work of knowledge.
Right. So which piece should I like spec out right now?
What about, well, you want the DAU the most, just from talking to you. Why don't you spec that out, in particular the interaction with the file system that it would require, and you'll also have to make a packaging model. How does it get packaged up and reconsumed? What is the interface? Basically, what does the package JSON of one of these components look like? And then what does a store look like? The components store that can assemble them all. I think that's the place to start. That sounds like the part that you like the most.
It's the part I've been thinking about the longest. Like I you know, my weakness is thinking about the economics of any of this, right? Like I don't think it makes sense to start with something that you can't sell. Like, is there a piece here that gets you funding quicker?
I think that a complete skeleton version of the full ecosystem, where I could sit there and do a demonstration end to end of each of the actors in it, would get funding the fastest. Okay. If you just had the DAU, like I would always sell it as a complete story. Like the revenue for the DAU becomes because of consumers putting in their credit card details in the store. That then goes back to the artists, and the DAU gets a cut of that because of the attribution model. That's right. That's why I would promote the DAU construction, right? But I'd be promoting the platform as a whole, because I'm like, well, there's no revenue from just selling. What are you going to do? Sell DAU licenses? Probably not. What you really want is a royalty stream of the products of the DAU.
Right. I mean, that's the main goal, right? Well, I mean, my main goal in all of it, I think, it has always been to make consumers closer to being artists, basically, right? Like, make it easier for you to understand, like, when you're consuming something, where it came from, and like involve you in the story of its creation a little bit more.
Yeah, so what gets funding first? The complete demonstration of the ecosystem. Right, but it's really about just promoting. Like I would say, why would you want to fund a DAU? Because you want to take a cut of everything produced with it, which is different, right? Ableton Live does not ask for that. They ask for a heavy payment up front. Some of it is recurring licensing if you want to keep getting updates. We're saying that the DAU is free. The updates are free. You can buy your own ones if you want them. You can make them. You can even sell into them. But the DAU takes a slice of everything you produce on it. So it's basically extending the AGPL license terms of the DAU out to the content made with it.
Yeah, that makes sense.
So you can start to look at the DAU and its produced data as one big software thing. And then you sell to people for being able to, like if you thought of a song as a software component, and the store is like this big piece of software, and you're just paying for little bits of that software. But, you know, it's completely offline. you own it forever insofar as you're not going to be, Spotify goes offline, all your playlist is still just there, like.
I worry about that. Hey, like the Spotify goes offline. That's like the burning of the Library of Alexandria. It's like a humanity critical event at this point.
I know. And then also, if you get censored out of Spotify, what does that mean? Like, where do you go then? Whereas this is like censorship resistant. Because it's run by the fans and the artists, I guess.
Oh, look at that. Okay. Like, I'm gonna need to. Is there anything kind of like simpler to build as an application using the current running platform, just to get my feet wet?
Yep. I guess you could watch the progress of the CRM, or poke around with that.
Are you developing that in the same repo?
Yeah, that's under WebDOS is where the CRM is being built. WebDOS equals CRM for now. I'll tease them apart once I've figured out what's generic and what's specific. But it was just too hard to make that boundary distinction early on.
Yeah.
So that storybook that runs out of WebDOS is the reference storybook that that's me every day now. I'm making that storybook up with those components. What I'm doing today is making an exporter for the blockchain, so you can export the whole file system as one single Merkle tree to give you the current view, so that I can reload it off of a GitHub URL inside the storybook, so that you can wrap each storybook component in a live running blockchain that was a snapshot of the application state.
Mm-hmm.
And so that I don't have to store the binary data or the blocks within the storybook repo. It just loads up, pulls the data in, off it goes. So the plan goes. See how that works out today, but I think it's pretty good. I think it's a better way of testing than just trying to provide mock data. It's like, here's a mock blockchain, and then you get all the functions and stuff that go with it as well. So it's like a fork of the application immediately.
And that's on your local machine right now, or that's in the code already?
That's in the code. Whereas some of the exporter is in the commits, but I'm working on that for the rest of today. The export is fun. It's like a special form of crawler.
Right. I guess it would be.
Yeah, but again, like, that's that distinction between a historical pulse link and a object internal link and an object external link. So it's like, here's the root of the file system, or any root. Give me the best view. Give me the current view that's consistent with this root hash. And then what I do is I load that up in browser RAM blockchain.
Mm-hmm.
And then the application thinks it wouldn't know, right? It's just getting the engine, and then the crisp gets dropped in at the top of the app tree, and then everything pops down. That doesn't really help you, though, huh?
No, it's fine. I just need to read code and run stuff.
Yeah. Okay. All right, so yeah, I mean, you can see from my latest commits what areas I'm focused on at the moment. But basically, that last story, the last set of stories under engine stories, that's where I'm fiddling with that, the bridge between the asynchronous world and the React prop object world.
And do you feel, though, like, I mean, is the core more or less stable right now, or is there more features you're going to push into the core?
The core is stable. the core has been stable for a couple of maybe 2 months. The core's been stable.
You don't have any more like changes that you want to put in it right away. The reason I'm asking is because I obviously there's iPorn that you want to pull out.
Yep.
But,
So iPorn also needs to include the exporter. It turns out they're all the same thing.
Yeah, I mean that makes sense. It's the same job, right?
Yeah, it's funny. I didn't realize that.
The reason I ask is because like just keeping a bit of a macro micro thing going on.
Right.
If I build an app, like I want to have a reason to dive into the core a little bit too, right?
Right.
But yeah, if it's just iPorn, then it's just iPorn. Like I'll just keep working on that. If I make stuff okay.
Were you asking me because are you like, is there an area that I need improvement on in the core?
What's the lowest hanging fruit there, basically? Because I want to.
All right. I don't have anything on my list. It's complete as far as I know, and now it's usage. Usage will be the thing that determines. Hey, I think that I need to make some changes somewhere. I wanted to talk to you about the effects model.
Right.
So that currently I'm just using the I/O channel to PS in and PS out of the isolation boundaries of each chain's reducer. But what I'd like to do is supply a function like the React hook use effect. And then, because if you think about a side effect context as being like the DOM, and it mounts somewhere, it either mounts on a single machine or it mounts on a cluster of machines that all get together and say, hey, we're ready, and then your side effect executes. And so I think I can actually put that model into the programming so that instead of having to supply your side effect functions as something separate to the reducer, it's all just the reducer. And so in the reducer, there's these, you call use effect and you give it the function. And then under the hood, I'll trigger an IO action that goes out. I'll reload the covenant in this new context that has side effects enabled. I'll run the exact same inputs that triggered the use effect call.
Yeah.
And then I'll run the use effect function in that new side effect available context and keep it there until the next time that the effect gets told to run or to stop.
Versus what happens now, you're manually responsible for like picking that up and reading the channel properly?
No, at the moment you need to supply your functions for side effects separately to the covenant.
Right.
I haven't completely finished I haven't made it fully load that in a nice, clean, automated way because I came up with this other side effect model. So I should maybe move to that so I won't do too much more work in that area.
Right.
So that'll be the next thing that I put into the core. It works good enough, I guess, is the thing. But
yeah, I think that's it doesn't really matter where you put the function for side effects. It's probably more of a pain in the ass to supply it like alongside the running code. Do you have any more constraints for like purity for the thing? Like,
I have completely abandoned purity. I'm like, if I didn't let any side effects out, was it pure?
Yeah, I mean the ultimate test is if everybody gets the same thing when they run it, then it's pure.
That's
right?
all that matters. Yeah, I know, right? And that could even involve some external calls. I think that formal purity versus practical purity are, like let's just go with practical purity because formal purity means a different language. And there's very few languages I know that have formal purity. Even fewer of them are like actually considered safe or something you can rely on. So
yeah.
What I can rely on though is practical purity. So
The only thing that concerns me a little bit there is if you're running with no validators everywhere, then it's not going to be possible to tell when you've been attacked.
Right, but so the browser engine is its own validator.
Right.
If it gets attacked, you're screwed anyway. I can't really help you.
Right.
There are no multiple validator functions available right now, but after we get stable and deployed at this site down in Hamilton, then we can start playing with running a second validator. Yeah, I've just been applying do I need it for the CRM? No. And then if I don't need it, I'll just defer it and just get these guys up and running and get the commercials going there. That seems the best way to promote the platform.
Then I think that like the most side effecty part of doing this auto fire up the other thing in another context and read from the IO channel is obviously the talking out to the outside world part of it. Using a use effect hook that results in an action going into a particular channel doesn't, I mean, it sounds pure already, right? It's just the everything else, the like fire up someone else and then get them to consume that. That's the impure part, right?
Yeah, that's the impure part. So the block making remains pure. The effects are impure and not my problem in a way, right? Like the block making is pure, remains pure. It's not like I make a block and then poke a hole in the containment boundary just because you called this one function. It's like is pure, stays pure. But this channel going out needs to be picked up by something that's willing to run in an impure context, fire it up and rerun it. Go from there.
Yeah, the only thing I would argue is I think probably the most sanity like enforcing condition you could put into side effects is if I'm consuming like a request for a side effect, the only thing I should be able to alter is that action basically, or just try and contain what that thing can respond to, right?
So the side effects always run after the block has been finished and sealed. Yeah. So there's no way for it to alter the current block in any way. If it wants to do things like, because I made use state be asynchronous, if you're in a side effect and you call use state, it just sends an action down the IO channel and waits for the response. So it's still able to look like it's running in the reducer, but it's connected by this pipe that sort of takes it out.
Right.
Because, I don't know. Sometimes I like use state being asynchronous, sometimes I don't. But it is good because it can be, you can call use state on anywhere in the application complex and you have the same interface. And you can also call it in the side effect realm and still it's the same interface. So right. I like it in that regard.
Yeah. I think what I mean more is like, don't let the thing that's actually executing the side effect code change anything other than adding a response with the thing that it just did,
Yes. What else were you worried it might change?
Anything else. I think it should only be allowed to do one thing. It's like if it digests a request, it needs to produce a response and that's it. Like it doesn't change the state. It can read from the state. It can.
No, you can't do it like that because you may need it to be long running. Like for example, if it holds the instance of libp2p,
right.
That needs to be long running, well beyond just the request that triggered it. It needs to receive updates over time so it can modify the state of libp2p as the application progresses.
Right.
So basically, this side effect model is a way to build all of the complicated parts of the engine as covenants. So like the network is a covenant using this side effect model to control the local network card.
When it changes the state, how does it do it? Because like, how do you get
You mean
how do you get that
how does-
change? So go ahead.
how does the side effect, a long running side effect, get a handle on the current state of that chain and then make a modification to it?
Yeah.
So it does that by sending an action back down the IO channel into the chain, requesting the state, which gets replied to once the block runs, and then sent back to the side effect.
Right. And then when it wants to change the state, does it just change it directly, or does it have to send an action to get somebody else?
It's an action because
Okay.
use state and set state are asynchronous. It's always an action-based thing. It's just that when you're running in the block making context, it's an action to your loopback interface. Whereas in the side effect context, it's an action to your IO interface.
Right. Right. So you think you're talking to yourself and you're talking to someone else, and they're only talking to you.
Yeah.
Yeah.
So it's a good way to, just by changing which channel the action goes into, the interface stays the same, but the context has moved.
Yeah. I remember this because like when we were working on the async await interface that we were building, I was going to propose to you that it should actually be a async iterator.
Right.
Like that's what we should build in. So like you can send one request and multiple responses back in that context.
Yeah. Making it be like an async iterator. There's a couple of ways that could be done. I haven't actually found a need to have that yet.
Right.
Progress bars, like informative progress bars, is one. But I mean, I love async iterators. Just let me preface what I'm going to say next with that. But how often do you actually use an async iterator day to day?
Yeah. So the other name for an async iterator is a stream, and I think increasingly everything on the internet is a stream, right?
Right. But the interface to it is not so common.
Right. Of course, because you can. And I think it sounds like you solved the same problem anyway by I assume you're closing down the old request and then firing back a new one when you process it back in the original context when you're changing state from a side effect executor, right? So like you would have like a...
Yeah, so there's two ways to get use state. There's use state and there's lock state. Lock state says, I'm about to change it. Everyone else get in line. And then when you receive that, you have the power to go set state. But if you just go use state, then I'm just like, read it to me at the instant I asked. That's it.
I see.
Right. So lock state, because lock state is required if you want to reach out across the tree, lock a remote state, and then change it. Like read a remote state and then change it, knowing that it didn't change.
Right.
There's another function in use state that I permitted, which was you can sort of try and set the state, but you can set it with some conditions. So you can get an error back if it changed out from under you in the meantime. I'm not a fan of that. I haven't actually used it. I might just disallow it because it feels like allowing timing information to impact the final state of the application complex.
Yeah. That's the kind of thing you're trying to avoid, for sure.
Yeah. So I'm like, look, if you're going to change the state, you need to lock it first, and then you need to set it.
Yeah, which is arguably the same thing as like telling somebody inside the sync boundary to do the work for you, right? I mean, I think it probably is, right?
Yes, it is. It is exactly it. You're basically reaching out to the synchronous boundary, asking for some stuff, but saying you're going to wait until it's done, and then back to the async world.
Right.
Yeah. So I don't know if that doesn't raise too many alarm bells. I figure I'll just chuck it in there because use effect is I love use effect in React.
Mhm.
And I really don't see the difference between the DOM and a side effect context.
No.
Right? They have
Yeah,
so
yeah,
many of the same features.
right. I mean, as long as like under the hood, it's all doing it the right way. I mean,
Yeah,
it's the same thing anyway, right? It's just
right,
like
right,
co-locating your code instead of not co-locating your code. It makes
right,
a program easier to read.
right. And then because UseEffect has these triggers, so that when some part of the covenant alters, you
Mhm.
shut down the effect and remount it or restart it. That's a useful lifecycle hook as well. Lifecycle event as well.
Hmm. Right.
Um, the final piece of the side effects saga,
Mhm.
no pun intended, is that if you run a side effect in the isolation context of the computer that started the engine, that's the hypervisor.
When you can side effect yourself.
Yeah.
Yeah. Um,
And
I
so,
mean,
for
as
example,
long as long as you're like logging sufficiently enough that you like have a repeatable outcome on the
well,
hardware level.
you're basically saying, here's the covenant, right? Like, here's the binary data that I'd like to execute in the CPU. So
Mhm.
that's sort of, that's easy to get comfortable with, executing data. We've been doing it for a long time. But then, this use effect hook, it's like the logging is just the interaction with the effect, which is minuscule, and the state interaction, which is just actions. So you can basically have this thin interaction record that does some heavy lifting in the side effect world.
You have to close over the environment in the hypervisor. Like that was always the hard part, right? You like just logging effects and states isn't enough
Mm.
to know that the environment has changed between successive runs in the host, right?
Yeah, so there's some the effect always needs to have some kind of reconciliation ability, which is what you get out of use effect and React anyway. Like, you still need to, if you're doing something higher, like interacting with the window variable, you
Mhm.
still need to be reconciling what the program wants versus what the window state is.
That's the second argument to the hook, right? The change watcher.
There, yes, but this was a different thing as well. It's more like saying that if the hook gets told that the state of the chain altered in a way, it would need to say it's libp2p, that is the thing that its purpose is. It would need to shut down the hook but not kill the libp2p instance, restart, and then re-grab the libp2p instance and make those new changes based on the state.
Right.
So that's I'll admit that's a little bit hairy, but it's not too dissimilar to dealing with something that some global variable in the window when you're using UseEffect in React. Like if your program state changes and you tear down your effect, window doesn't care, it's still there.
Right. Yeah. I think it's like declaring what environment you're interacting with should be enough, right?
Yeah.
I mean, assuming that your side effect execution system doesn't, sneakily interact with some other part of the environment, which they always do.
Right, but that's part of what you need to specify when you invoke a covenant. You're like, here's the
Right.
isolation boundaries that I'm allowing.
Right.
And so when I run the shell covenant at the root of the engine, I'm like, basically no isolation, full system.
Right.
And that's how I can fire up a network connection and do all that kind
So
of stuff.
you really should, like, to be polite, you should have it, like, you should have it boot inside of a Docker that you've built beforehand, basically.
You mean for doing a different non-hypervisor related effect?
Even for the hypervisor one, right? Like I think booting inside of something where you have like complete control over the environment.
Yeah, but you're basically saying that I'm on the same level as the invoking process,
Right.
which is correct, which is what you want.
Right.
And whoever instantiated the process is responsible for the containment of the engine itself.
Right.
I mean,
let me say, I do think you're correct. Like that is what the hypervisor is. It's a side effect.
yeah,
It should be. That makes the most sense of anything, rather than making it full blocks. Like that's
yeah. It's not full blocks. It's a control layer that operates on, what did you call it? The audio rate. It's
Mhm.
the machine is the audio layer. The hypervisor is just the signal layer.
Mhm. Right. Yeah, I do worry all the time about environment stuff because it's always the thing that makes everything suck when you're programming, right?
Uh-huh.
Like you can't put enough time and effort into like careful control of the environment because
Yeah.
but like that's not a solvable problem, right? Because like you could do everything perfectly and then there's a solar flare when you fire up the system, right? Like it's unfortunately we live in a universe where the environment is not in our control.
No. But we do quite well in our little boxes.
Yeah.
Um,
Yeah, so, I mean, I think that's an elegant solution to the hypervisor problem. Like, you're basically saying the blocks for the hypervisor are nothing more than the record of the actions of going out to try and change it.
no, the more than that, the declarative state that you want its side effects to be in. So
Right.
the state change of the hypervisor is saying, I want this system state. The
Mhm.
system tries to meet that, and if it can't, it'll send in an action saying that it can't do this particular thing. The hypervisor processes that and flashes back a new state of like, okay, then I want this state. And then the reconciler tries to make that happen. So just like how the React reconciler tries to get the virtual DOM reconciled with the real DOM with as
Mhm.
little effort as possible, sometimes it can't do it and it'll throw back an exception which needs to be handled by your app.
Right. It's
But
a bit of a weird state
declarative,
to be in. It's a bit of a weird state to be in, right? Because like you can't revert the hypervisor. You can't roll it back to a previous state when it failed to listen to you.
Right, but that's always going to be a problem with declarative programming. Like
Right.
you're declaring what you want, and then you do need to do something when the reconciler can't meet your declarations. You could restart, for instance.
Right. Restart the whole node, yeah.
Yeah, or just restart the networking component, or restart the disk, or there's a lot of logic that can take place in the reconciler and not in the covenant.
Mhm.
So basically, it allows you to supply the code for the side effect in the covenant, but you don't have to only communicate using the state. You can do a bunch of stuff off in your side effect, like it's freeform programming out there.
Right.
Just your interface back is the blocks. That's all.
Yeah. Okay. So I mean, the other type of scrutiny that I'd want to apply to the design is it still possible to try and encapsulate more and more of the pieces of the running system that's actually hosting everything as chains themselves, like to turn it into more of a.
Well, I've got network as network is a chain
Mhm.
where the side effect is the libp2p node plus the level DB store. So how things worked out is that network and storage are actually the same thing. You can't have one without the other. If you start with a disk store, you imply a network. If you start with a network, you imply a disk store. It's actually really painful and no point to run one and not the other, especially because you want to heal You know, like you're like, hey disk, where's this thing? Oh, hey, here it is. Oh, the hash is wrong. Oh shit. And then it goes out and grabs it off the network. So to the engine, it just sees it as disknet.
Right.
It's just like, give me this. Okay, hey. Sometimes it takes a while. So that's a chain, like that's a dedicated chain. And when you're in the engine and you want to turn on disknet, it starts up a new chain, which has the covenant that handles the logic for network operations in it. And then it causes a side effect, which opens up the port to listen to if you told it to listen, or makes connections to other peers. So that's already a chain. What else would there be?
I mean, do you want to try and encapsulate the idea of compute itself? I think
Like
there's value to it.
multi-threading.
Yeah.
Yeah, multi-threading could be done in that way.
Or, I still really like the idea of being able to swap out an entire network in place of my CPU,
Yeah. So that's that. I haven't settled on a design for what's the best way to manage a vastly multi-core cluster. So in your local machine where you've got cores, it's best to split by simply split by engine operation. So when you're processing the block and hashing it, it's best to break that up amongst threads, and then one thread for writing, and that's that. But when you're across multiple CPUs, like in a Lambda environment, what's the best way to coordinate between them all? I'm not exactly sure. I think it's that each Lambda function is represented by a blockchain where there's like this shared consensus chain that says, okay, here's all the Lambda functions I'm aware of. As they come on and drop off, like you sort of grow the chain model and shrink the chain model, and then you distribute load based on some kind of sharding of the chain ID. So
Right.
like which Lambda function gets which jobs is like a broken up by chain ID, because that only works because the Lambda functions are of equal capability and the hash space is reasonably random. So
Right.
So, you split the workload here and there, but the thing is, like different chains are going to do different things. So it's not really a performance-based split. It's a numerical split.
That's the right design for that level, right? Because if you want a semantic split between the workload, that's like on the application level. If you want a numerical one, that's kind of more on the hardware level, right?
I think I want more of a queue-based distribution, like the Lambda workers report their load factor periodically to the central chain, and then any new work gets sort of spread out by who's idle.
Like an Erlang supervisor, basically.
Yeah, sort of. And then what you can do with that is you can assign lock for a given chain ID to that Lambda, so it doesn't have to wait for the DB round trip to guarantee exclusive lock. It's like it's got it by default because that's just how the sharding algorithm worked. And then it only has to deal with lock contention between its cores, not ever between other processes. So that's why I like the central pre-sharded model. I don't even think that's a word, but it's by doing the locking ahead of time based on a formula and a pattern, it's faster than doing it by a database write. Yeah. So I mean, getting the programming model to be able to effortlessly handle like 10,000 cores over the space of like 5 seconds, and then go back down to 2 cores and another 10 seconds later, that's I think that's a major milestone to hit, right? Because right now it's still single computer. I can't, right? Whereas these programs, because the interface should scale out like that, we should be able to test it with like horrific numbers of chains,
Yeah,
right?
a
Like,
test with a billion chains.
well, I mean, I've got to, so I can load 20,000, and then it takes it's still 1 millisecond to add a new chain each time, ignoring the computational cost of generating that new chain. Adding the new chain to the parent still stays linear at 1 millisecond from about 10 chains up. The speed's about the same, more or less.
Wow.
So I don't know where the upper limit is. I haven't set out to discover that yet. I think it's in the millions before we'll notice a different kind of a barrier.
Right.
Like, but yeah, I only need 20,000 right now. Works great.
I mean, I can't imagine. I think the most records I was simultaneously messing around with was like 500,000, and that's like a lot, right?
That is a lot. Yeah, that is a lot. And I think that you've got other problems if you need more than that in a single chain. So,
Well, you have a human problem. Like, you're probably coordinating so many people at that point that you can't.
yeah.
You're going to lose your mind, right? Like,
So I mean, the current design's got good scale, but it's still, I haven't touched any of the CPU scaling aspects. I'm gonna scale single computer first and then Lambda after that. But the single computer scaling actually needs to happen a lot faster than I'd previously imagined, because if you want to run one of these apps in another tab, it's going to load up the same KV store and it's going to fail to get lock. So lock needs to be in a service worker. So you're already threaded at that point.
right? Yeah, I see what you're saying.
So every tab will have access to the service worker that does the chaining. So
Right.
So
I don't think you need a full threading model for that. I think you can just write that into your like KV store side effects, right?
yeah, but
If you ran,
once you've got one extra thread,
Mhm.
you might as well have them all. Like the effort to get the first extra thread is probably 90% of the effort to get all the cores.
right. You don't think that can be left as like a like there's interleaving there, right? If you start to deal with sort of the way the boat is floating out behind you, it looks like you're on a boat. So that seems like a specific case, right? Where you're always only going to have one.
Yeah. So like, I guess when I think about that problem, I'm like, maybe I should hit the true multi-threading problem at that level, and then to use it in Lambda is the same thing.
But like now you're kind of interleaving different hypervisor components again, and there's going to be more of an interaction there than you count on, I think, right?
Yeah, there always is. I don't have to solve that problem to be able to get this deployment done.
Right.
But yeah, you're absolutely right. There's like that and a whole bunch more other stuff to contend with. But it's really like that's an ancient problem, is how do you deal with multi-threading locally versus multi-threading on the network? Do they have the same interface? Do they behave the same? And then on top of that, we're trying to say, look, we're making a multi-threading interface that looks the same no matter what. And then we have to decide what's the best way to efficiently split that up amongst the hardware that we have available.
So that one I'm going to probably not be able to stop thinking about.
Yeah, it's a really fun problem.
is is another core the same thing as a disk and a network?
I think so.
I mean, if you glue those things together, well, I don't know. I mean, the big problem is basically once you start sending things that are intended for one, then the state of the other is has an effect on how that one will work, right? If you start gluing stuff together, if you start coupling it like that, all of a sudden the order that you're talking to them matters.
Yeah, yeah. I think it's all about just making sure that the disk net is the single coordination point.
Right. So you're asking for more compute from the network.
Yeah,
I guess why not?
that's what you're doing, right? And,
Mm-hmm.
it's like it could have been sent to you over RAM using shared memory. Could have been sent to you over the network. Who knows? You could get to it years later from when it was asked for.
I get it. So it's kind of like saying just someone else do this for me, but
Yeah, right?
you're,
It's like
you're
someone else.
you're in my trust boundary.
Yeah.
That's probably the hardest part about it, right? Is figuring out what kind of, how would you rule out whoever else is going to take it?
Yeah, well, that's the locking or work distribution thing. So in your trust boundary, you can do work distribution. Outside your trust boundary is work contention, and that's kind of the key element of the public system. Is that the work contention needs to include payment, and then once the payment is secured, then the contention changes. It's now bidding. So I guess those are the three levels: intercore, inter lambda, or trusted cluster, and completely untrusted.
Yeah, nice. The trusted cluster feels like you should treat it the same as intercore.
Yeah, I know. It does feel remarkably similar.
Sorry, I just realized it's 20 after 4. I need to hop off.
Oh, good, man. Hey, that was fabulous going through this document with you.
Yeah, well, it's something to work off of, and I'm gonna.
Yeah.
Now that you say that the core is frozen, I'll just stop thinking about it. Okay.
It's not. Well, it's not frozen. It's just that it works enough for me. There's loads more to do. I don't know what the next push should be. So I'm not trying to say don't work on it. I'm trying to. The last year and a bit, I've been trying to build it by using it, and just building enough of what I need. That's been going okay so far.
That does tend to be that works well when there's one person working on the code, right?
Yeah, I mean, look, our burn rate was like $1 million a month to try and do all this stuff all at once for a theoretical customer, and we're getting further just by picking one customer and trying to satisfy just that one than we were with 40 Muppets running around the place.
Right. So I mean, it does kind of motivate why building another application is a good idea. Is different customers have different needs, right?
They do. Yeah.
Do you have any other customers in mind that aren't just my fantasies? I mean, building a customer model for the app that I talked about does seem to be.
Yeah. So the next customer that I got lined up is will be in the warehousing space, because turns out that so there's this trucking company down the line that needs the CRM. They also need tablets in their trucks to guide the drivers, so that there's less reliance on trained drivers that can remember these very intricate routes. So the tablet means that you don't need to train anyone, and that different drivers can do other people's routes without it being a problem.
Right.
That same, what's required to get the blockchain platform running on the tablets is the same as what's required to get it running on Android scan guns for warehouses. So
Right.
like there's a warehouse that has this thing's huge, but the guns that they use have to have Wi-Fi, and so the Wi-Fi is like, you know, to deck out a warehouse and Wi-Fi is like 30K type of thing. Whereas if you had these guns that were offline capable, plus may or may not have cellular connections, suddenly you've saved the cost of Wi-Fi and your guns are more commoditized. Second of all, the current application they use for their warehousing is very latency sensitive. They have multiple warehouses. They have a Microsoft SQL based application that has to sit in a terminal server. So now this thing's like 32 cores, like this whopping great thing, because it has to handle all the users coming in so that they have zero latency to the database, which is co-located with the terminal server. Whereas if you had this application that was capable of handling their I think it's some staggering number, like 100,000 different stock keeping units. But if you had a system that could handle that and all ran on the guns with no cloud server required, and was latency insensitive, that saves a lot of money.
Mhm.
So that's sort of, I can take the exact same code base for the tablets in the truck and I can test it with these gun scanners, because, you know, as much as I can tell from looking at the application and the database and the environment that it runs in, it's pretty simple. It's just a lot of crud with like crystal reports on top. And I'm like, well, you know, that's not really that hard, right?
But I mean, 95% of everything is CRUD, right?
So that'll be the next customer. I'm just trying to focus on things that can benefit from offline first. Hopefully, you know, there'll be some other tracking applications that can be used that are, I can say, hey, make this thing the same as this thing but slightly different, because that's easy to farm out that work, as opposed to, hey, figure out how to make a synchronization mechanism that works with this custom Merkle tree structure that we made. Works less, yeah. But yeah, that's what I'm heading. If you can find some extra customers that can tolerate being test customers, great. But I don't think it'll take more than maybe another half dozen, and we'll be like, I think we're probably good enough that we can list the company at that point, because it's like pretty clear what it does. Revenues are predictable, the model's predictable. You know, everything, you can sort of put it on paper and submit it to an auditor and say, look, we want to issue shares based on this model. Give us the issuer's license, please. And then off you go.
Cool.
Yeah, ring that bell. Ding, ding.
Okay, well, I'm going to jump off.
Cool, man.
Have a good one.
Peace. I'll see you later.